Hello viewers, welcome to the another segment of microwave. In this segment, we are going to discuss the last segment, that is the transverse magnetic mode of our microwave subject. So, in case of the rectangular waveguide, there are two modes. One is transverse electric, another is transverse magnetic. The transverse electric mode is discussed earlier. In this segment, we are going to discuss the transverse magnetic. There are three types of the mode in case of the transverse magnetic mode of the waveguide. They are cutoff mode, even consent mode, and the propagation mode. Now, let us recap what is gamma. Gamma is root over m pi by a square plus n pi by b square minus k square. You are already aware about all the terms in our earlier lecture. Let us discuss the modes one by one. First is case A, which is cutoff mode. In this case, k square is equal to omega square mu epsilon is equal to m pi by a square plus n pi by b square. So, in this case, gamma is equal to 0. And what you already aware of, that gamma is equal to alpha plus j beta. So by identity, alpha is equal to 0, also beta is equal to 0. That means there is no propagation. So omega c is equal to 1 by root over mu epsilon into root over m pi by a square plus n pi by b square. And what you are already aware of from the class 12 conception, that omega c is equal to 2 pi f. So fc is equal to 1 by 2 by root over mu epsilon into root over m pi by a square plus n pi by b square. Now, what is mu and epsilon in case of the air? In case of the air, mu is equal to mu naught and epsilon is equal to epsilon naught. So here Fc is basically u by 2 root over m pi by a square plus n pi by b square. But in case of the air, this u is converted to the velocity of the light, that is c. So the equation becomes Fc is equal to c by 2 root over m pi by a square plus n pi by b square. Now let us discuss the second case, that is the even consent mode. Here k square is equal to omega square mu epsilon less than m pi by a square plus n pi by b square. So gamma is equal to alpha and beta is 0. And what you already aware from our previous lecture, that this alpha is the attenuation constant. So the wave is totally attenuated. Now let us discuss the propagation mode of the transverse magnetic mode of the rectangular waveguide. In this case, k square is equal to omega square mu epsilon is greater than m pi by a square plus n pi by b square. So gamma is equal to j beta and alpha is equal to 0. This is our aim. That means from this mode onwards, the wave will propagate. This Fc is known as the cutoff frequency of the transverse magnetic mode. Whenever you are transmitting a signal or information through the waveguide, you have to generate the information more than this frequency Fc. In case of the transverse magnetic mode, beta is equal to root over k square minus m pi by a square minus n pi by b square, and Fc is equal to omega c by 2 pi is equal to 1 by 2 pi root over mu epsilon into root over m pi by a square plus n pi by b square. So Fc is equal to u dash by 2 into root over m pi by a square plus n pi by b square. So this is the cutoff frequency. Then what is the cutoff wavelength? From the class 12 level conception, you are already aware that lambda c is equal to u dash by fc, which is equal to 2 by root over m pi by a square plus n pi by b square. So beta is equal to omega root over mu epsilon into root over 1 minus fc by f square. In case of the transverse magnetic mode, what is the diagram of TM21 mode? In this case, m is equal to 2, n is equal to 1. So from the end view, you will observe the two circles, and from the side view, you will observe the three segment of the electric and the magnetic field. Now let us discuss the variation of eta in case of transverse electric and the transverse magnetic mode. The variation of the eta will be, in case of the transverse electric mode, it will deviate from 1 to eta dash. In case of the transverse magnetic mode, the signal will be varied in the lower side from 1 to this eta dash. Now let us discuss what is the dominant mode in case of transverse electric and the transverse magnetic mode. What do you mean by the dominant mode? In this mode, the wave will start to propagate in case of the transverse electric and in case of the transverse magnetic. The dominant mode in case of the transverse electric mode is TE10. So in this case, is equal to 1 and n is equal to 0. In case of the transverse magnetic mode, the dominant mode is TM11. So in this case, m is equal to 1 and n is equal to 1. Whenever you are trying to propagate the signal or the information, you have to start from this mode onwards. You may ask question, is there existence of TE00 and TM00? I will answer no, it is not possible. Because if m is equal to 0, I will answer no, it is not possible, because m is 0 and n is 0 will derive and convert all the equations to 0. That is not possible practically. So that is all about the rectangular waveguide. In our next segment, we are going to discuss another important part of the microwave. Till then, practice the equation. If you have any doubt, call us, email us, and clear your doubts. Thank you all. Bye.